Today, we are diving into something that's a real game changer in how we build and ship software in containers, a super powerful technique called multi-stage builds.
I love this quote because it just nails a huge problem we've had in software for ages. Basically, our final product, the thing we ship to users, ends up being filled with all the junk from how we built it. All the tools, the compilers, the temporary files, they all get bundled up right alongside the actual application.
And this is where the real problem lies, right? The stuff we need to build the software is the polar opposite of what we need to run it. For building, you need the whole heavy-duty factory, compilers, SDKs, build tools. But for production, you just want the sleek, finished car, the application itself, a minimal runtime, and nothing else.
So, what happens when you have this conflict? You get something called image bloat. Let me tell you, it's a way bigger deal than it sounds. This isn't just about wasted disk space. This is a critical inefficiency that costs companies real money and real time.
Yeah, bloated images are way more than just a little annoyance. They have a measurable, painful impact. They make your build and deployment pipelines crawl, which means it takes longer to get new features out. They drive up your cloud bill because you're storing and transferring huge files. And when traffic spikes and you need to scale up fast, good luck waiting for that giant image to download. But honestly, all of that pales in comparison to the biggest risk of all. Of all of those issues, there's one that should really keep you up at night, and it is all about security. Every single extra file or tool in your image is a potential liability.
Think about it this way. Your attack surface is just all the different ways an attacker could try to break in. The more stuff you have in your image, well, the more doors and windows you're leaving unlocked. Leaving a compiler in a production container, that's not just leaving a door unlocked, it's like leaving a full set of lockpicking tools on the welcome mat.
Okay, so how do we fix this mess? The answer is actually super elegant. It's an architectural shift that was introduced in Docker, and it's called multi-stage builds. And this is where things get really, really cool.
The core idea is genius in its simplicity. You separate the workshop from the showroom. You build your application in a messy, chaotic workshop that has all the tools you could ever need. But then you take only the finished, polished product and put it in a pristine, minimal showroom for everyone to see.
Let's walk through how this works, all inside a single Docker file. First, we define a builder stage. This is our workshop, using a full Go development image. Inside there, we compile our app. Then, and this is the key, we start a completely new, squeaky clean stage from a minimal base image like distroless. And now for the magic trick, that copy-from equals builder command. It's like a teleporter that just beams our finished application from the workshop into the showroom, leaving all the mess, all the tools, and all the source code behind.
So, there are two crucial bits of syntax here. You use from to start a stage, and you name it with as. Then, copy from is how you grab files from a previous stage. Now here is a pro tip, and please listen to this one. Always name your stages with as, like builder or release. Referencing them by number is a recipe for disaster. The second you add a new stage, your whole build breaks. Naming them makes your Docker file readable and so much more robust.
And what's so great about this pattern is how incredibly versatile it is. It's not just for compiled languages like Go. Let's take a look at how you can apply this idea to solve unique challenges in different programming languages.
Take Node.js, for example. The big headache isn't a compiler. It's that gigantic node_modules directory. It gets packed with development tools, testing frameworks, linters, bundlers, all stuff that is completely useless in a production environment and just adds bloat and security risks. The solution here is called the pruning pattern. You use one stage to install everything, dev dependencies included, to build your application. Then, in a second stage, you install only the production dependencies. This gives you a clean, lean node modules folder, which you then copy into your final image along with your app. It's brilliant.
Python has a very similar challenge. You know how many popular libraries, like NumPy or Pandas, actually need a full C compiler and a bunch of development headers just to be installed? Well, you need all that stuff to build them, but you definitely don't want it hanging around in your final image.
And for that, we have the wheel builder pattern. Same logic. You do all the heavy C compiling in a big builder stage, which creates these pre-compiled packages called WHL files, or wheels. Then, your final, lightweight stage doesn't need the compiler at all. It just installs these ready-to-go wheels. Simple and clean.
See, it doesn't matter what language you're using. The core strategy is always the same. Build in a heavy, tool-rich environment. then copy just the essential artifacts into a minimal one. Whether it's a static binary for Go going into a Scratch image, which is literally an empty container, or pruning dependencies for Node.js, the principle holds true.
Okay, now for my favorite part, the payoff. Why are we going through all this trouble? Because the results, they aren't just small improvements, they are absolutely staggering.
Just look at these numbers. A C++ application built the old way could easily be a 1.3 gigabyte image because it's packed with the entire compiler toolchain. With a multi-stage build, we get that down to just 20 megabytes. No, that is not a typo. That is the power of this technique.
We are talking about size reductions of over 90%, in some cases as high as 98%. Just stop and think about what that means for a second. It means faster deployments, lower cloud bills, and quicker scaling, all from making one simple change to your Docker file.
But the most critical improvement, without a doubt, is security. By throwing out all those unused tools, we eliminate all of their known vulnerabilities, or CVEs. A standard Node latest image can come with over 500 of them. A lean, multi-stage build using a minimal base like Alpine can drop that to less than 10. This lets your security team stop chasing noise and focus on what really matters.
So, what should you take away from all this? What are the key practices to master? First, always name your stages. Second, keep that separation between your workshop and your showroom really clean. Third, use a Docker ignore file to keep your build context lean and fast. Fourth, look into using build cache mounts to speed up your pipelines even more. And finally, use a linter to catch mistakes early. Mastering these will make your builds lean, fast, and secure.
At the end of the day, multi-stage builds are so much more than just a technical trick. They represent a fundamental improvement to the entire software delivery lifecycle. By shipping only what you need, you make your applications faster, your cloud bills smaller, and your systems dramatically more secure. The only question left is, what will you do with all that power?